Look at this geometry problem. It looks incredibly simple, right? A right-angled triangle sitting inside a circle with a radius of 5 centimeters. Find the area. Easy peasy. But a massive number of students see this on a test, rush through it, and get it completely wrong. Today, we are breaking down the trap, why your first instinct is probably wrong, and how to solve it in seconds. So, what's the wrong way? Let's look at what most people do. They see radius is 5. They remember the area of a triangle formula. Area equals half times base times height. Then they look at the drawing and think, oh, the bottom line looks like the radius, so the base is 5. The vertical line looks like the radius, so the height is 5. They plug it in, half times 5, and they get 12.5 square centimeters. Wrong. Absolute trap. If you look closely at the diagram, those green lines are chords of the circle. They don't start from the center. They go from edge to edge. They are definitely not equal to the radius. To solve this, we need to unlock a hidden rule of geometry. It's called Thales's theorem. Whenever you have a right-angled triangle perfectly inscribed inside a circle, meaning all 3 corners touch the circle's edge, the longest side, the hypotenuse, must be the exact diameter of the circle. No matter how you tilt or stretch the triangle, if that corner is 90 degrees, that long slanted side is cutting the circle right down the middle. Now that we know the secret rule, let's actually solve it the right way. Step 1. Find the actual base. If the radius of the circle is 5 centimeters, then the diameter is double that. So, 5 times 2 equals 10 centimeters. Because the hypotenuse is the diameter, we can turn the triangle in our minds and use that 10 centimeter line as our base. Step 2. Find the maximum height. The problem doesn't give us the other sides, which means it's looking for the maximum possible area. To get the tallest possible triangle on a 10 centimeter base inside a circle, the peak of the triangle has to reach exactly to the very top of the circle. And what is the distance from the diameter line to the top edge? It's the radius. So, our maximum height is 5 centimeters. Now we just plug our real numbers into the formula. Area equals half times base times height. That means area equals half times 10 times 5. Half of 10 is 5. And 5 times 5 equals 25 square centimeters. And boom! The maximum area is 25 square centimeters, not 12.5. Don't let geometry diagrams trick you into assuming lengths just by looking at them. Trust the theorems, not your eyes. If you want to smash more math traps like this, hit that subscribe button, leave a comment if you caught the trick before I explained it, and I'll see you in the next video.